CLARI is a little squishable robot that can passively change its shape to squeeze through narrow gaps with a bit of inspiration from the world of bugs. CLARI, which stands for Compliant-Legged Articulated Robotic Insect, comes from a team of engineers at the University of Colorado Boulder. It also has the potential to aid first responders after major disasters in an entirely new way. Several of these robots can easily fit in the palm of your hand, and each weighs less than a ping pong ball. CLARI can transform its shape from square to long and slender when its surroundings become cramped. The researchers introduced the miniature robot in a study published in the journal Advanced Intelligent Systems. Right now, CLARI has 4 legs, but the machine's design allows engineers to mix and match its appendages, potentially giving rise to some wild and wriggly robots. It has a modular design, which means it is very easy to customize and add more legs. Eventually, the researchers would like to build an 8-legged spider-style robot that could walk over a web. CLARI is still in its infancy. The robot, for example, is tethered to wires which supply it with power and send it basic commands. But the researcher hopes that one day these little machines could crawl independently into spaces where no robot has crawled before, like the insides of jet engines or the rubble of collapsed buildings. In its most basic form, the robot is shaped like a square with one leg along each of its 4 sides. Depending on how you squeeze CLARI, however, it can become wider like a crab or more elongated like the cockroach. In all, the robot can morph from about 34 millimeters wide in its square shape to about 21 millimeters wide in its elongated form. Each of CLARI's legs functions almost like an independent robot with its own circuit board and dual actuators that move the leg forward and backward and side to side, similar to a human hip joint. Theoretically, that modularity might allow CLARI robots to take on a wide variety of shapes. The researchers see their current design as the first in a series of CLARI robots that they hope will become smaller and more nimble. In future iterations, the researchers want to incorporate sensors into CLARI so that it can detect and react to obstacles. The group is also examining how to give the robot the right mix of flexibility and strength. Ultimately, the team wants to develop shape-changing robots that don't just move through a lab environment but a complex natural space, in which the machines will need to bounce off obstacles like trees or even blades of grass or push through the cracks between rocks and keep going.